Hello and welcome to today's live stream. We've got 7 more questions. Topics should be listed in the description. Anyway, our first one is the stationary points for the sec 2x cos 2x. I'm going to give you, I think, 5 minutes to start with. We'll see how the class does in the classroom. One minute to go. Right, here we go. So we want to find the stationary points of the curve y equals sec 2x minus cosec 2x. So what we're going to do is we're going to differentiate that. And just get myself a pen. Oops, that's gone a bit messy. Let me change the settings. So it's gone a bit funny. Hopefully that will improve. Okay, yes, we've got a better. So we've got dy by dx will equal sec 2x will go to sec x goes to sec x tan x, so sec x 2x will go to 2 sec 2x tan 2x. Minus cosec goes to cosec goes to minus cosec cot. So minus cosec 2x will give us a plus 2 cosec 2x cot 2x. And to find the stationary points, we need to solve when that equals 0. So what we're going to do, I'm going to put this all into sines and coses. That's much easier to solve, I think, at this stage. So I'm going to get, this is the same as sine 2x. So it's not the same as sine 2x, sorry. Tan 2x is the same as sine 2x over cos 2x. And sec 2x is the same as cos 2x. I've just written them in a different order because I was working them out in my head that way. And then we've got cosec 2x, so that's going to be 1 over sine 2x. And cot is going to be cos 2x over sine 2x. So what we get this is equal to 2 sine 2x over cos squared 2x plus 2 cos 2x over sine squared 2x. Okay, and what we're going to try and do is we're going to try and add these together as a single fraction. So I'm going to times top and bottom of this by cos squared, and top and bottom of this by sine squared, and bottom of this by cos squared. So that is equal to 2 sine cubed 2x plus 2 cos cubed 2x all over cos squared 2x plus sine squared 2x. Now cos squared plus sine squared is just equal to 1. Either way, we can just make the top equal to 0, so we can just get rid of all of that. Now, if we go back to sheet 9, I think we solved this question already. Let's have a look. Let's go back. Sheet 9. There we go. We solved this question already where we got sine cubed x plus cos cubed x, and we solved this is equal to 0, and we got all these solutions on the last sheet, which we did earlier this week. So you can find out that x will equal 3/4 pi, or in this case 2x will equal 3/4 pi, 7 pi by 4, 11 pi by 4, and 15 pi by 4. So if we go back to this, we know that 2x, because we can just divide it out by 2 to start off with, so therefore 2x from sheet 9, okay, from sheet 9 we know that 2x is equal to 3 pi by 4, 7 pi by 4, 11 pi by 4, and 15 pi by 4. And so therefore x will equal 3/8 pi, 7 pi by 8, 11 pi by 8, and 15 pi by 8. And then we got the y values that go with those. It's minus 2√2, if you put that in, 2√2, minus 2√2, and 2√2. So those are the coordinates of stationary points. It doesn't ask us to find the nature, so we won't do that. That's enough for this question at this stage. Right, question 2. is on the familiar theme from our rocket. We've got the velocity time is taken, v is equal to 27e to the minus 0.1 t. Find the time taken for it to reach a height of 250 meters. I'm going to give you 2 minutes to do these. If you've been following this series, you should be getting good at these. Off you go. I'm just giving you an extension of 30 seconds. It seems to be what my class is going to need. Okay, so we've got this problem with our Formosa 3 and it's ready to take off, and we're going to just go through this question. So let's just draw a quick picture of what's going on with a pen rather than a rubber. Here we go. It's being temperamental. Right, here we go. Still being temperamental. There we go, I've got a pen now. Here we go. So I'm going to draw a picture of this. Now, if we're doing v times 27e to the minus 0.1t, that's going to be an exponential where it goes down. And when t is equal to 0, then this is going to be equal to 1. So that 20 is equal to 27. So it's going down like that from 27. Okay, so we're going to integrate, and we want to find the time taken to reach a height of 250 meters. So we're going to integrate from 0 to x, our height, 27e to the minus 0.1t dt, and that's going to be equal to 250 meters. The whole area now is under here is equal to 250 meters. So let's integrate this. So we get minus 270e to the minus 0.1t, because we're going to divide by minus 0.1, because when we differentiate we times by it. So we divide by minus 0.1 to get from 27 to minus 270. And we're going to do that between x and 0 to make it equal to 250. Let's put x in, so you get minus 270 e to the minus 0.1t. Put 0 in, that gives us a minus, that's a plus 270. And e to the 0 is 1, so it's just going to be 270 here. Let's just rub that out and make it neater. And that's equal to 250. So therefore, we're going to get minus 270 e to the minus 0.1t is equal to minus 20. So e to the minus 0.1t will equal 20 divided by 270. And we take natural logarithms of both sides. Sorry, I shouldn't have a t in here because I put an x there. So let's just rub out all those t's and turn them into x's. There we go. Rubber's being temperamental. So we get minus 0.1x will equal natural log of 20 over 270. So x will equal minus 10 times the natural log of 20 over 270. And that comes out to be 26 point, I think 03, looking at my answer. I can't read my own writing. Somewhere between 02 and 03. I essentially put this into your calculator and you'll get the exact value out. Right, let's look at the next question and see how long I think that should take you. This shouldn't take very long at all. I'm just going to give you 60 seconds. You should be able to do this in 60 seconds by now. Let's see how you get on. Right, so there's your 60 seconds. Sorry, I just got distracted with my class. So here we go. Given the cos theta equals 4/5 and theta is between 0 to 90, let's find an exact value for cos 2 theta. Now we should know by now that cos 2 theta, and you should know these all off by heart, then you know which ones to use, is equal to 2 cos squared theta minus 1. So therefore cos 2 theta will equal 2 times 4/5 all squared minus 1, which equals 4 over 5 is going to be 16 over 25 times 2 gives me 32 over 25 minus 1, and that's just going to give me 7 over 25 for cos 2 theta. Right, next question. Here we go. So we've got big Newton's cooling problem. And I think I'm definitely going to give you 5 minutes of this. I'll read through it just to make sure you get a chance before you get started. Gordon Ramsay's chef extraordinaire removes a souffle from the oven when it's cooked to perfection. It has a temperature of 150 degrees C. The kitchen, a sweltering crucible, testosterone-filled expletus, has a room temperature of 30 degrees C. Timing is everything. If the waiting staff do not get the souffle to the table before the temperature drops to 138 degrees, it will collapse. In its first 20 seconds out of the oven, the temperature of the souffle drops to 148 degrees C. How long do terrified waiting staff have in order to get the souffle to the table? And you can have the formula, the Newton's cooling formula. So the temperature is equal to the temperature environment plus the original minus environment times by e to the minus RT, where you'll need to find R. So off you go. I'm going to give you 5 minutes to have a go at that one. 1 minute to go. Right, so on this question, let's just put the numbers of the environment into the question. So we know we've got the temperature is going to be equal to the environmental temperature, which is 30, plus T naught. Now T naught in this is going to be 150, minus temperature environment, so that's 30, e to the minus RT. Now we know that in the first 20 seconds, it has dropped to 138 degrees. Oh no, it's the wrong one. It has dropped to 148 degrees. So 148 will equal 30 plus 150 minus 130. So that's going to be 120 times e to the minus RT. And t was 20 seconds, so it's going to be minus 20 lots of r. So we take the 30 away, we get 118. Divide by 120. And that will give us e to the minus 20r. So we can see from this, if we rearrange this, we get natural log of 118 over 120 will equal minus 20r. Undo e by taking natural logarithms of both sides. Then we divide by minus 20. So r will equal minus 1 over 20 times by the natural log of 118 over 120. And that comes out to be about 8.4 times 10 to the minus 4. So what we're going to do is we're now going to put all of that into our question to see how long we have to get this souffle to the table. So we know that we've got 138 is the temperature we must get it to the table by. And we know we're going to get 30 plus 120 e. Now we know what r is. We've got minus t times 8.4 times 10 to the minus 4 up here. Okay, if we substitute this now into our expression. So we get 138 minus 30 gives me 108. Then divide by the 120. And that's equal to e times minus t to the times minus 8.4 times 10 to the minus 4. So all of that stuff there, what we're going to do is we're going to take natural logs of both sides. So we get natural log of 108 over 120 equals minus t times all that stuff. I'm not going to write it out again. So therefore t will equal minus 1 over all that stuff. 8.4 times 10 to the minus 4 times by the natural log of 108 over 120. So that will shove that all into your calculator and you should get 125.37. So they have about 1 minute, 2 minutes and 5 seconds. So it's approximately 2 minutes and 5 seconds to get that souffle to the table. Our next question, a bunch of differentiations to do. I'll give you, let me just have a quick look. I think that it's going to give you 5 minutes. Probably a bit too much. Let's see if you can, how my class gets on with 3 minutes to do these 4 derivatives. Right, 50% of my class have managed to finish that in the time, so let's see how we get on. So if we're going to differentiate this, the first one's nice and easy. It's just a standard, use the formula. So cot goes to minus cosec squared x, and tan goes to plus sec squared x. You just learn those off by heart and then just write them out. B, so we know that tan goes to sec squared, but we've got tan 2x, so that will go to 2 sec squared 2x. So 2 times 3 is 6, so we get 6 sec squared 2x. And for part C, we know that cot goes to cosec minus cosec squared. So we've got 3 lots of that. So it'll be 3 lots of minus cosec squared times by 4. So we're going to get dy by dx will equal minus 12, cosec squared 3x. And then we've got the tan 6x will go to 6 sec squared 6x times by the minus 2, so that's going to give me minus 12 sec squared 6x. And now we've got the tricky bit. Okay, those are all easy to knock off in about a minute. This is the one which you needed 2 minutes for. So we got tan of cot. So we got a chain rule. Now you might want to let u equal to cot x and y equals tan u. So du by dx will equal minus cosec squared x, and dy by du will equal sec squared u. So dy by dx will equal dy by du times du by dx, which is just going to be sec squared u times minus cosec squared x. But u is equal to cot x, so we get sec squared of cot of x. There's no real simple way to, real way to simplify that. That's how you do it. And you should really be trying to do those in your head. You should have thought to yourself, okay, I'm going to differentiate the cot x and I get minus cosec squared coming out. Then I differentiate the tan, I get sec squared of whatever's in the middle. So do try and get to the stage where you can do those in your head. So next question. Nice straightforward one. I'm going to give you just 2 minutes to have a go at this triangle problem. Right, so here we go. We're going to draw a little triangle here. And we're going to put P, Q, and R here. And so this side will be 3, This side will be 5 and this side will be 6. And we know that QPR is equal to 2 theta. So we're going to use the cosine rule to show that cos 2 theta equals 5/9. So we know that 5 squared will equal 3 squared plus 6 squared minus 2 times by 3 times by 6 times by cos of 2 theta. So what we get is we get cos 2 theta will equal, if we take this to this side and then that to that side, so what we're going to get is we're going to get the 9 plus the 6 squared, so 36 plus 9 is 45, minus that 5, so that's 25, divide by all of this. So cos of 2 theta will equal, that's going to be 20 over 36. And we know we want to show that that's equal to 5 over 9. So 9 goes into that 4. 4 goes into that. So we get 4 into 20 is 5 and 4 into 36 is 9. Now we want to find an exact values for sine theta. So we know that 1 minus 2 sine squared theta is equal to 20 over 36. Because 1 minus 2 sine squared theta is equal to cos 2 theta. So sine squared theta will equal the 1 minus 20 over 36. And it will equal half of all of that. Okay, take the 20 over 36 away from the 1, then divide by the 2 to get a half of all of that. So that's going to leave me with 16 over 36, and a half of that will give me 8 over 36. So we know that sine squared theta equals that, and we can cancel this down. 4 goes into both the top and the bottom, so that goes into that 2 and that goes into that 9. So sine squared theta equals 2 over 9. So sine theta will equal root 2 over 3. Now it could possibly also equal minus root 2 over 3. But it won't do that because we know that the obtuse angle is going to be up here, and this will be an angle actually was going to be a reflex angle, because it's sine theta can only equal a negative when it's either back here or it's greater than 180. So we know our answer is sine theta equals root 2 over 3. All right, last question. 5 minutes to do this one. Bit of factor theorem with a little bit of logs thrown in at the end. 1 minute to go. Okay, here we go. So another 50% record of getting this done in the 5 minutes. So A, we want to show that x plus 1 is a factor of f of x. So therefore we do f of minus 1 using the factor theorem. And we do 3 times minus 1 cubed minus 4 times minus 1 squared minus 5 times minus 1 plus 2. So we get minus 3, and then we're going to get minus 4 plus 5 plus 2, and that equals 0. Therefore, by the factor theorem, x plus 1 is a factor. So we can write this out. Now, there's two ways to factorize this. You could do long division. I've become used to do that, or get my students to do that. I've become much more a fan of just getting them to just say, look, there's x plus 1. So x times 3x squared will give me the 3x cubed. And then I've got 1 times 2 will give me the plus 2 on the end. And all I've got to do is work out how many x's I need. Well, 3x squared times 1 will give me 3x squared, but I need a minus 4x squared. So if I put a minus 7x here and times that by x, that will give me my minus 4x squared. Check on the x's. Minus 7x times 1 is minus 7x. 2 times x is 2x. And they combine to give you minus 5x. So we get x plus 1. And then we get 3x squared minus 7x plus 2, which factorizes to give 3x minus 1 times x minus 2. And so we can see that x will therefore equal, does it ask? It just says factorize, so we don't need to solve. But I'm just going to work out what x is at this moment in time. If I was to solve this equals to 0, I'm just going to put this in brackets. And I'm going to get I'm going to get a third here, and I'm going to get 2 there. Now, what I can realize here is this is just exactly the same thing. Yep, I got 3x cubed, 4x squared minus 5x plus 2 if x is natural log of 2. So I'm going to let x equal the natural log of 2x. So if that's true, then natural log of 2x must equal these values. So natural log of 2x must equal minus 1 or 1/3 or 2. So if I raise both sides to the power of e, so I get 2x will equal e to the minus 1 or e to the 1/3 or e to the 2, because natural log, if you raise both sides as a power of e, then that undoes the natural log. So x will equal a half e to the minus 1 or a half e to the 1/3 or a half e squared. And we're asked to do these to 2 decimal places, so you can get your calculator out at this stage, and that gives you 0.70 or 3.69 or 0.18 to 2 decimal places. Okay, and that concludes the stream for today, and I'll be doing what did we do today? Sheet 10, I think, sheet 10, so I'll be doing sheet 11 tomorrow at 5 p.m. See you then.